Hi friends, welcome to our channel Vidya Vihanga. As a part of the series Machine Learning with Python, we have started the basic and important linear algebra library NumPy. Now let's see some of the functions which are involved in NumPy library. I am here at the Jupyter Notebook and let's get started. Initially, I am importing the NumPy library and I am giving it an alias name as NP. I am using a variable ARR and using the array function, and I am taking a 3 by 3 matrix 4, 5, 6 and 7, 8, 9, and parallelly I want to see what is present in ARR. In the ARR variable we got a 3 by 3 matrix. Now what if you want to extract a particular number at a particular position? For that we can use ARR of 1, 2. Let's run this. So we have got an output of 6. Here in the NumPy library in Python, initially the indexes started will be from 0. When we compare with R, the indexes will be starting from 1. Now let's forget about R language. Now we are using the Python language. So let's just remember that the indexes will be starting from 0. So this is the 0th index row and this is the first index row and this is the second index row, and parallelly the 0th index column, first index column and the third index column. Now we have what we require is that the first index row and the second index column. So it is obviously the number 6. We can also extract the same number in a different manner. Let's look at that. Even this gives the same result to us. It's 6, right? Now, what if we want to extract a subset from the original matrix ARR? Let's do that. ARR of 2, 1, colon. Now let's see what's the output of this. We have got an sub-array 2, 3, 5, 6. Now let's try to understand what has happened here. I have mentioned in the rows, I haven't mentioned the start. So it will be starting from the index 0th row and it will be proceeding further. But I have mentioned here as 2. It will be excluding this 2 and it will be considering only the first 2 rows, that is index 0th row and index first row. And coming to the columns, it will be getting started from the first column and it continues. So it will be ignoring the first column which has 1, 4, 7 numbers and it will be starting from the first column index. So 258, 369. But however, already the first 2 rows are selected and coming to the index, the columns 2. So the answer will be 2, 3, 5, 6. That's the output, what we have got, right? And next, moving on, what if we want to know which numbers are greater than a particular number or not? ARR greater than 3. Let's see the output of this. We have got true, false matrix. Generally, we won't be interested in what is true and what is false, but the numbers which are true will be considering those numbers. For that, we have to modify somewhat the above statement ARR of ARR greater than 3. Now let's try to run this. So these are all the numbers which are greater than 3. Obviously it should be. And moving on further, let's see some important functions present in the NumPy library. Those are known as travel and pattern. Let's see how these work. Let us consider a as a variable, and I am using it the array function, and 1 comma 2 comma 3 right here, and 4 comma 5 comma 6. Next I'll be taking another variable b, np dot array 7 comma 8 comma 9, 1 comma 2 comma 3. That's it. My two variables a and b of dimension 2 comma 3, and I'm using another variable RA which indicates ravel function, and I am applying the ravel function to a variable, and FL variable which indicates flatten function, and I am applying the flatten function to B. Now I want to change one number in RA as 100, and FL similarly I want to change one number in FL even. Now let's run this. Now let's see what is present in A, what is present in B. As we can see that we have applied the ravel function to A, so the change has been done to the original matrix even. That should be 1 comma 2 comma 3, but it has been modified to 1 comma 100 comma 3. So if we apply the ravel function, that will be affecting the original matrix even. If we apply the flatten function, we have applied here for the variable b, so there won't be any change in the original matrix. So that's the difference between ravel and flatten. Moving forward, I'll be introducing a small trick or whatever it may be. Instead of keep on typing np.array 1 comma 2 comma 3, so we'll be now modifying that, and I want to take a variable arr1 np dot random dot rand int of 1 comma 100 comma 3 comma 2. So I want to see what is present in arr1. Let's run that. We have got an array without any waste of time and without much using our strength. So what if we want to sort these array according to their numbers? Let's sort that. Now again, let's see what is present in arr even. As we can see here at the last row, initially in arr1 it's 99 comma 93, but after sorting it has been changed to 93 comma 99. So that's the reason why we'll be using the sort function. arr1 dot argsort. Let's see what this does. Here we have got the indexes numbers in a sorted way. For better understanding, I'll be taking another variable arr2 is equals to np dot random dot rand int of 1 comma 100 comma 3 comma 2 this time. No worries, whatever it may be. Even I want to see what is present in arr2. So here we got another array. Now I want to sort it according to their arguments. or we can say according to their indexes in a simpler language. So already they have been sorted out. So we are getting 0, 1, 0, 1, 0, 1. What if we try to modify the shape of the matrix itself as 2, 3? Now let's run this. Now just we can find some difference here. So let's try the org sort. We can see it here easily. So 57, 39 and 72. These are all ordered according to their ascending order, but we have got their indexes, not the numbers itself. If we apply the sort here itself without the augment, we'll be getting the numbers. But if we use the arc sort, we'll be getting the indexes. So that's the difference between arc sort and sort. What if you want to just like transpose our matrix? It's quite simpler. Here are 2 dot t. So we have transposed our matrix just by adding dot t. Now, what if we want to append some more data to our existing matrix? Let's do that. Again, arr3 is equals to np dot random dot randint of 1, 100, this time 3, 3. Let's consider. I want to see what is present in arr3 at this time. Oh, this is our matrix arr3. Now, just I want to add some more data to it by using the append function to it. np.append arr3 of 1, 2, 3. Let's say axis is equals to 0. Now, I want to see what is present in arr3 when. Okay, this hasn't been appended. Let's assign it to another variable and let's try this. Yeah, this time it hasn't been worked. So one more row has been appended to the matrix arr3 and our new array will be arr4. And next, what if we want to do a dot product between two matrices which will be playing a key role in our machine learning? So let's even do that. This time I'll be considering a very small matrix, a larger one, and dot randint of 1, 100 of just 2 by 2 matrix. And I am considering another matrix. Similarly, random dot randint of 1, 100, 2. I'll be doing a dot product by using just np dot dot. That looks something weird, right? Yeah. I'll be assigning this to some C variable and I want to see what's present in C. Let's run this. Yep. So after dot product, we have got this array. Oh, let's see. This will be a bit confusing. Let's cut this out. If we want to see what is present in A and B, first of all. So let's run this. Let's print A here. Let's print B here. And this time C is equals to np dot dot of A comma B. Let's see what's present in C now. So You can just calculate it out. It will be accurate. It should be. Yeah. So what if we want to I'll be changing the sizes of the matrices. Let's try with that even. I'll be changing this as 2, 3 and I'll be running this. I want to see what is present in A now and B and dot product. There is an error. This is why, because for applying the dot matrix, the dot function, we have to maintain the dimensions should be same. The columns of the first matrix and the rows of the second matrix should be same. However, this is the basic functionality we'll be knowing from mathematical background. Now let's go further and do some operations. These operations may be mathematical or some universal array functions, whatever it may be. Let's see what are those. For this event, I am taking np dot random dot randint of 1, 100, 2, 2 and b is equals to np dot random dot randint of 1, 100, 2, 3 this time. Let's change that. Now let's see what is present in A first of all. Oh, just run this. Yeah, A, and this is B. Now let's try to run these two matrices A and B. Again, there is an error. So what it states clearly is that the sizes of the matrix or the shape of the two matrices are not equal. So let's try adjusting that. 2, 2. Let's run this. Now A, and this is B, and this is B. Similarly, we can do it for A minus B even, A modulo B even, A star B, and the point here we have to remember is that this A star will be a casual multiplication, and there is a lots of difference between the casual multiplication of a matrix and the dot product of the matrix. What if we want to add a constant to a matrix? Then it can be done. Yeah. So I want to see again what is present in A. So just I want to subtract constant 50 from this. So why I have shown this is that even it can support a negative numbers in an array. And moving forward, I want to show some of the universal array functions. What are these universal array functions? Universal array functions means they can be sine, cos, tan, log, exponential, and etc. Even we can work out these by using the NumPy library. Let's see an example of that. Now to see A again, just use sine np dot sine and A. When we apply sine function to a matrix A, this is the output of that. Similarly, we can use tan np dot sqrt, which is the square root of the matrix. We can find even the square root of all the numbers present in the matrix A. So this is it. And next, we can even find out the exponentials of the matrix A. This is the one. And similarly, np dot log A, and this is the one when we apply the logarithmic to each and every element in the array A. And finally, I want to show the last thing. If we consider again a matrix A, let's run that A. So this is A, and let's see what is present in B. Now A dot sum. Let's run this. So if we do it as sum, it will be adding all the elements present in the matrix A. It will be 228. What if we want to add only the numbers present in the columns? We have to simply mention it as axis is equals to 0. That indicates columns. So here we go as 91, 137. So if we add the columns itself, then we'll be getting the 91, 137. What if we want to add the rows? Just we have to mention it as axis is equals to 1. Let's run this. Here we go. So this time it's 92, 138. Obviously 44 plus 48, 92, and 47, 89 is 136. By this, we have came to an end to the NumPy library. In the next videos, I will be starting the pandas library, which is the built-in library which is built on the NumPy library. We can say it's used for data cleaning, preparation, and for fast analysis. That's it for now. Thank you. Please like, share, and subscribe to our channel Vidya Vihan.